Okay, everybody, what I'm going to do now is just going to go through your oxidation states homework. So thank you very much for giving me your scores on the email. If you haven't sent me your scores, please do, because it just helps me keep a track on you. And, keep in touch. Some of you have been keeping in touch. Some of you have been keeping in touch better than others. So it'd be nice to hear from you. Anyway, I'm going to go through these now with my sort of working out of how to do oxidation states. Feel free to skim through the questions that you had no trouble with. So an oxidation state of +4. I'm looking for one of these has got an oxidation state of +4. So I'm going to go through them really, really quickly. You need to be quick too. Right, oxygen, each oxygen in a compound is -2. So I'm going to show you a little trick that I use here. This is how I would teach it in a lesson. I'm trying to work out the oxidation state of this nitrogen. I know there are 2 oxygens and each oxygen is -2. So here's a nice little visualization for some of you. Each oxygen, if you start at an overall 0, an oxygen takes you back -2, another oxygen takes you back -2. That means the nitrogen needs to take, its oxidation state takes you all the way back so that the overall is +1. So how do you get from -4 to +1? The oxidation state of this must be +5. I don't know if I'm just overcomplicating things here, but that's typically how I would teach it in a lesson. So chloride here, sorry, the chlorine, I know that the oxygen is -2. So again, I'll draw one of these diagrams first. There's 0. Each oxygen is -2, so there's 3 of them. -2, -4, -6, -2, -4, -6. The chlorine needs to take me all the way back up to -1. So it needs to take me to there. So that means the chlorine is +5. I hope that diagram sort of works for you. It's not essential. It's just another way of visualizing it. Right, H2SO3. So here I know that oxygens are -2 and I know that hydrogens are +1. So I've got 3 oxygens. -2, -4, -6, -2, -2, -2, -2, -4, -6. I've got 2 hydrogens which are +1, +1, +1, +1, +1. That means the sulfur must be +4. That's the answer. I'm not going to bother with the bottom one because the sulfur is +4. Of course, I don't actually use this. What I do in my head is I go -6, 2 pluses, that takes me to +4. Overall it's 0. The sulfur must be +4. You've got to practice them. You've got to be able to do them. They are incredibly common. And, from my experience, good kids who get their head around it now. Sorry, just opening a can. Good kids of Pepsi. Good kids who learn this at the time and don't get stuck on it find it so easy, and it's easy marks in the exam. I always despair when people can't do this. Right, I'm going to have a look through these now really, really quickly. Each hydrogen is +1. So what I'm doing here, I'm just going to work out the oxidation states rather than look through each one and see which is the right combination. Nitrogen is correct oxidation state. The hydrogen is +1, +1, +1, so +3. So the nitrogen must be -3. That means it's either B or C. The oxygen is -2, so each nitrogen, the oxygen is -2, so each nitrogen must be +1, +1. All right, so that doesn't help me. It's either B or C. So HNO2. So each oxygen is -2, -2, -4, -2, -4. The hydrogen is +1, +1. So how do you get back to a neutral compound overall? It must be +3. This one. Okay, next question. Which of the following shows chlorine in its correct oxidation state? Chlorine's an interesting one. Chlorine is typically It's typically -1 because it's in group 7. But chlorine can have a variety of oxidation states, as you're about to find out. Right. So I'm not going to go through each row. I'm going to just work it out. Hydrogen is +1, so the chlorine must be -1. So I'm either looking at this one or this one. So there's no point looking at B or D. In this one, oxygen is -2, -4, -6. Potassium is a group 1 metal, so that's +1. So -2, -4, -6. +1 takes me to -5. Chlorine must be +5. The answer is C. Do you notice how that's a shortcut to how some of you will have attempted it? All right. I just work out the answers first and then, I don't know. Which of these is not a redox reaction? So let's have a little look. Gonna get these sorted. So how do you tell redox reaction? This is a very common question as well. Which of these is not a redox reaction? And this is where you're expected to just use your oxidation states and be able to write them really quickly. So I'm going to show you what I mean by that. Right, I'm going to go through this equation and I'm going to write the oxidation states really quickly under each element. I'll do the ones I know first. Oxygens are -2, hydrogens are +1, oxygens are -2, oxygens are -2, hydrogens are +1, oxygens are -2. Elements in their standard states, unbound, are 0. The copper here, now then, an easy way to work out the copper here, SO4 is a 2- ion, that's copper 2+, that's +2. I can do the sulfur later if I need to. That's copper 0 and copper +2. This copper here is, that's -2, so this copper here is +1. Each copper there is +1. So it looks like, without even looking at the sulfurs, that sulfur, by the way, is +6, and that sulfur is also +6. If the oxidation states of anything change, it's redox. So what you're seeing here is you've got 2 coppers, and both of them are +1, and they end up, one of them ends up as +2 and one of them ends up as 0. The oxidation states change, the oxidation numbers change, the oxidation states change, so that is redox, because you see a change in the numbers. All right then, this one, magnesium oxide. Magnesium oxide is magnesium 2+ ions, oxide 2- ions, so the oxidation states are +2 and -2. Hydrogen +1, chlorine -1. Magnesium +2, chlorines are -1 in a compound, hydrogens are +1. Right, look at this. The magnesium here is 2+, the +2, the magnesium here is +2. The oxygen is -2, the oxygen is -2. The hydrogen are +1, the hydrogen are +1. The chloride is -1, the chloride is -1. That is not redox because the numbers don't change. So that's the answer. I'm just going to go through these really quickly then. Chlorines are -1 in a compound, -1 in a compound. The mercury must be +2, the tin must be +2. The mercury is 0. The mercury is +4. See, the numbers change. The mercury has gone from +2 to 0. The tin has gone. So that's redox because the numbers change. And of course, 0, -1. Well, that's all I needed to look at. It's 0. Chlorines are 0 over here because they're the elements, and they're -1 here. It's redox. Another one will have changed as well. -2, so that's going to be +4. -1, so that's going to be +2, so that's changed as well. That's redox. All right. So you've got to be good at your oxidation states. Excuse me. I've got a bit of a cough. Oh dear. I think it's hay fevery type stuff. I don't think I've got coronavirus. Right. In which reaction is the metal oxidized? All right then. +2. I'm just looking at the metal. There's no point looking at the others. Right, copper here. So, well, actually, iodide in a compound is group 7, so that's going to be -1, +1. So the metal goes from +2 to +1. That means the number is getting smaller. When a number gets smaller, you are reducing its size. So that is, the metal is getting reduced. So it's not that. Weird. I'll look at them in a minute. The metal is 0 because it's the elements, and at the end the metal is, now Mgs, that's an S2- and that's an Mg2+. The metal is +2, 0 to +2. It's getting oxidized. See how I missed these two out because they come up in year 13. If you do work this out though, this is iron surrounded by 6 waters. Waters are neutral, so that iron is actually +3. And on this side it is actually +3 as well. These things in square brackets are known as complex ions. That's +2 and that's +2. So anyway, the point is that. So when you get asked these, look what I am doing, and you have to do the same as well. You have to be confidently putting these numbers in. The quicker you can do it, the better. You don't have to do it as quickly as me, but that is what's expected when they say which of these is a redox reaction. So here's another one. Which of these is a redox reaction? So I'm looking at, do the oxidation numbers change from one side of the equation to the other? If they do, you're dealing with redox. All right, calcium oxide -2, +2, -2, -2, -4, so that must be +4. And on this side, each of them is -2, -2, -4, -6. Calcium is a group 2 element in a compound is +2, +4. Nothing changes, not redox. Silicon is +4, +4. Calcium is +2, +2. I'm looking at this one, right, and I'm seeing sodium in a compound +1, sodium in a compound +1. I'm seeing SO4 ions, SO4 ions. I don't think that's redox. If I can't be bothered working it out, there's going to be a more obvious one. It's down the bottom. I'm starting off with elements and I'm ending up with a compound. 0, 0, +2, -2. That's redox. I could go into all of these, but I'm looking for something where if you've got an element on one side and you've not got an element on the other, if you got it like magnesium and then magnesium in a compound, you know the elements are 0, so that's an easy one to choose. So you could have taken a while on that, or I'm just, I've done it like that, easier. Right. The thing is with these redox questions, we really, really use this in year 13. So you will be struggling with it a little bit. You won't. I'm sure you won't be super duper confident with it, but you'll get loads of practice. And I bring up redox equations most lessons next year. You have to be good at it. Anyway, what is the reducing agent in this reaction? So hopefully you realise that the reducing agent gets oxidized. All right. That's how a reducing agent gets oxidized. Oxidizing agent gets reduced. The reducing agent gets oxidized. So I'm going to look through here and have a little look to see. Okay, the reducing agent. Gosh, I've got quite a lot of work to do on here to work out the oxidation states. I know the answer to this, but I'm going to do it as if, we're doing it from scratch. We can look at shortcuts next year. Right then. The potassium over here is +1. The potassium over here is +1. It's not potassium. That's potassium in a compound. That's potassium in a compound. All right. What are we dealing with over here? We're dealing with H pluses. Well, H pluses, it refers to like the acid of the H plus. So that hydrogens over this side are +1. Hydrogens over this side are +1. It's not that either. So we're dealing with, is it C2O4 2-, which must be, there's 2 H pluses, which must be, if I get rid of those, this thing here, C2O4 2-, or is it CR2O7 2-? CR027 2-. All right. So it's hard, this. So I'm going to work out the oxidation states of everything in these little bits here. And then I'm going to try and find the oxidation states of the chromium and the carbon over this side. All right. CR2O7. So 7 oxygens. That takes me to -14. Did you follow what I said there? 7 oxygens in a compound takes me to -14. I'm going to show this in a little diagram. All right. There's 0. -2, -4, -6, -8, -12, -14. So I'm at this point, -14 from the 7 oxygens. Now I've got 2 chromiums that are going to take me back to -2. That's my target point. So I've got to go doosh, doosh, oops, oop, boop. So I've got to get back to -2. So this is a jump of 12. Each chromium is +6. I hope that works for you anyway. So anyway, this side, the chromiums are +6. I'm going to go over to this side now and check the chromiums out. Right. This is chromium or dichromium sulfate. I don't know what you'd call that. So this thing here, sulfate, SO4 is a sulfate ion. There's 3 of them. The sulfate ion is SO4 2 minus. I could do it like that. Could I do it like that? Yeah, SO4 2 minus. And there's 3 of them. -2, -4, -6. Each chromium is +3. Alright, you're going to have to try and work that one out yourself. But I just took the sulfate SO4 2 minus as being sulfate, the ion. Each chromium here is +3. The chromiums on this side are +6. The chromiums on this side are +3. The chromiums are getting reduced. Hang on a minute. That's not that. So it's not you. So if I was at this point in the exam and I was running out of time, I'd just tick this. But since I've got a bit of time, I'll just check it. I am looking for these carbons here getting oxidized. All right, the oxygen is -2. This is a C2O42 minus ion. Oh gosh, -8. -8. Each carbon here is +3. Each carbon here is +4. Do you see how good you've got to be at working out oxidation states? The carbon goes from +3 to +4. The carbon is oxidized. A reducing agent gets oxidized. Boom. Nobody said it was easy. There's a song there. Nobody said it was easy. Don't know who sings it. That'll bug me, that. Anyway, that one. You've got to learn how to do oxidation states, otherwise you have not got a chance. Right then, question 8. In which reaction is hydrogen acting as the oxidizing agent? Same thing again. Oxidizing agents then get reduced. So what I'm looking for then is an oxidation number going down, getting smaller, getting more negative. So I'm just looking at hydrogens. Very quickly then. Hydrogen element 0. Hydrogen Is that hydrogen getting reduced? No, it's getting oxidized. It's going up. Oxidizing. I'm looking for a hydrogen getting reduced. 0. These are hydrogens in compounds. +1, +1, +1. Not that. Hydrogen 0. Hydrogen in a compound +1. Not that. Must be this. 0. Right. This is a sneaky one. Hydrogen in a compound is +1, except when it's bonded to a sodium, lithium, potassium, a group 1 element. A group 1 element there, sodium is +1. The hydrogen is -1. It's known as a group 1 metal hydride. The oxygen goes from 0 to -1. Boom, it's getting reduced. There you go. Look that up in your oxidation state rules. Hydrogen is always +1, except when it's -1. It's one of those rules, and that was testing that. Maybe in an exam you'd realise that if you were really good at oxidation states, you're realising this is all going 0 +1, 0 +1, 0 +1. So by a process of elimination, you tick that. Whatever, but that's how you'd work that out. Right, I'm going to stop there for this section of the video, and I'm going to call this video Redox multi-choice or something like that. Okay, thank you very much. I'll straighten that up, and I'll leave this bit there.